Hi everyone, my name is林亚葶, and today I will be introducing my project, which is about human versus LLM, explore language processing capabilities using fMRI and sentence transformers approach. Large language models are known for their capabilities and effectiveness in performing human-like tasks. However, sometimes they produce awkward and unnatural responses, or they fail to deliver the correct answer. Therefore, currently we need a stronger and more human-like AI and a method to fine-tune large language models. The specific goal of the study is to investigate the possibility of using human neural response to enhance AI. And to do so, the study explores the human brain's and LLM's capabilities, centering on comparing their language processing mechanisms. If the human brain outperforms the LLMs, that means we could use neural response to fine-tune LLMs. Moving on to the implementation methods. The idea is, while a subject listens to a story, their fMRI data, which is their neural response, is collected every 2 seconds. We process the story scripts to obtain the words spoken during each interval. Next, the fMRI and story script data are grouped into segments. The next step would be to obtain the fMRI embeddings and LLM embeddings. So the fMRI embeddings in the same segment are averaged to obtain the segment's representative fMRI embedding. The strings of words in the same segment are passed to a sentence transformers model to obtain the segment's LLM embedding. Lastly, we need to obtain emotion labels. We use Cloud to assign an emotion label to each segment based on its text content. For a subject and a story they listen to, there will be 2 datasets in the end, fMRI embeddings and large language model embeddings, and their emotion labels. The study focused on 17 stories listened by a subject. We take the fMRI and large language model embeddings from all 17 stories to train 2 separate classification models that predict emotion labels. Lastly, we evaluate the models using a testing data and compare the results. This is the experimental flow. In the first method, we implemented logistic regression models and conducted cross-validation using stratified k-fold. In the second method, we implemented random forest models with 2 different random states. Here are the experimental results. The models were assessed using micro F1 score. The mean micro F1 score of the 5 folds from the cross-validations in method 1 shows that the LLM model has a better performance. The micro F1 score of the logistic regression models shows that the LLM model outperforms the fMRI model again. Lastly, in the results of method 2, we see that the fMRI model outperforms the LLM model when the random state is 77, but it performs worse when random state is 42. Right now, the experiment has some flaws. Therefore, in the future, I will focus on improving fairness and accuracy of the result, such as to revise segmentation method, to assign emotion labels on my own instead of using Cloud, to use multi-label instead of one label, to decrease the amount of possible emotion labels, and finally, to increase the training data size. This is the end of the presentation. Thank you so much for listening.